Hello students. In last class we are already completed Electro Chemistry part 4. In that video we are discuss how to calculate the EMF of any cell by using Nernst equation. If you have any doubts, please go through that video and again continue watching this video. Okay? So let us start today. In this session we are going to discuss what is the relationship between the Gibbs free energy and EMF of the cell, and also what is the relationship between the inert cell and equilibrium constant. Let us start today topic. Let us start the topic name. Relationship between the delta Z and inert cell. So let the concentration of the reacting species using in this process is unity. Means what we are taking the reactants here. The reactants should be take unity concentration. Means 1 molar concentration should be take. Then then E cell is become inert cell. Then the value of delta Z naught, there is a small mistake here, delta Z naught. The delta Z naught is equals to minus NF E naught cell minus NF E naught cell. Okay, so this already this expression is already is there. So this is the expression. This is the expression. Small mistake, make it is not. Delta Z naught is equals to minus NF E naught cell. In this delta Z naught, what the delta Z naught is, that delta Z naught is nothing but gives free energy. Okay, if you go very depthly, it is standard gives free energy. Delta Z naught is equals to standard gives free energy. N, what N here? N is nothing but number of electrons are involving in this process. Suppose in this reaction Zn is Zn is converted into Zn plus 2, means here how many electrons are involved? 2 electrons. It means that we have to take in the place of n 2 electrons. F value is always constant. F is nothing but Faraday. F is nothing but what? Faraday. The Faraday value is 96,500 coulombs. 96,500 coulombs. That is the F value. Then inert cell they will be provided in the problem. So substitute these values, then you will get the delta Z naught. Once again I am repeating, delta Z naught is equals to minus NF E naught cell. Here delta Z naught indicate the standard free energy, N indicate the number of electrons, F indicate the Faraday, that value is 96,500 coulombs. E naught cell is the standard cell potential that will be provided in this problem. So our the next concept is relationship between standard EMF and equilibrium constant. You know already about the equilibrium constant. This is already discussed in the first PUC. Standard gives free energy and equilibrium constant. Sorry, not standard gives free energy. It's a EMF, standard EMF, that is nothing but E naught cell, and equilibrium constant. Equilibrium constant is represented by Kc. The standard formula is E naught cell is equals to 2.303 RT divided by NF log Kc. This is the main relationship between the standard gives free energy. Sorry, I'm very sorry. It is a main relationship between the EMF of the cell, standard EMF of the cell, and equilibrium constant. Okay, where in this expression Kc is equals to equilibrium constant, E is equals to standard EMF of the cell, R is equals to gas constant, R is equals to gas constant, T is nothing but standard temperature, that is equals to 298 Kelvin temperature or 25 degree centigrade. F is equals to Faraday value. Here we are substituting the R value in this expression, where I make the tick mark. In this expression we are substituting the R value. What is the R value? R value is 8.314. 8.314. T value is already given 298 Kelvin, and F value is 96,500 coulombs. After substituting the all values, then we are getting, this is the expression. The naught cell is equals to 0.0591 divided by n and and log Kc. Okay, this is the expression we are getting after substituting the R value, T value, and Faraday value. So let us go to the solving a problem. Standard EMF. What is the meaning of standard EMF? Standard EMF is nothing but E naught cell. They given, that is called as 1.1 volt. Calculate the standard gives free energy. Very easy level of problems. They given E naught cell, and we have to calculate the gives free energy. Even they providing to you equation. Why they providing to you equation, I will tell you. It's a redox equation. Hmm? They're given options also. It's a CET level questions. This is the four options they're providing to you. See, all the options is very closely related. It's very fondly related, but it is similar with one answer to another answer. Okay, let us go to solving of our problem. How to solve the problem? So let us go to the first formula substitution. Formula is delta Z naught is equals to minus NF E naught cell. Okay, so this is a formula. Delta Z naught is equals to minus NF E naught cell. Then substitute the values. The values here is n is equals to 2. How can we say that n is equals to 2? I already mentioned to you in this equation what they given here. Zn is converted into what? Zn plus 2. Copper plus 2 is converted into what? copper. Means Zn, you take any one. You take any one. Zn is losing the 2 electrons or copper is gaining the 2 electrons. In this equation, zinc is losing 2 electrons. That 2 electrons only taken by copper. Okay, that's why the total number of electrons is not 4. Listen clearly, the total number of electrons is not 4. The total number of electrons is equals to only 2. Okay, that's why the n value is belongs to 2. N value is belongs to 2. And the Faraday value is 96,500 coulombs. In our cell they are already providing, that is 1.1 volt. Substitute the values one by one. In the place of n we have substituted the 2. In the place of F we have substituted the 96,500 coulomb. In the place of inert cell we are substituting the 1.1 volt. Then we are getting minus 21227 is nothing but 21,227 joules is a joules. If you want to convert it into kilojoules, then into 10 to the power of minus 3, or entire value is divided by 1000. That is also fine, both are same. Then divided by 1000, then we are getting delta Z naught value in form of kilojoules. In PU examination, either you will report your answer in the form of joules or in the form of kilojoules, there is no issue. But in the competitive examination, it should be what the option is giving, that you have to go. The option is given there is, okay, the option is given here is in the form of kilojoules. That's why which option is correct among here? Do it this among this, which option is correct? This is the correct option. Third option is correct. Okay, I hope you understand. If you understand, let us go to the next problem. Next problem is, let us go to the question. The cell in which following cell reaction is occur. Let's try to observe this cell reaction. Here unit cell they are providing, and calculate the standard Gibbs free energy and equilibrium constant. This is a very interesting question. Both you have to calculate. First, standard Gibbs free energy followed by equilibrium constant. Please see the question once again. Try to write down neatly by making pause. Just pause it. You will write the answer, write the question properly. Let us go to the formula. Delta Z naught is equals to minus NF inert cell. This is the first calculation. Based on the problem, N value is equals to 2, F value is equals to 96,500 coulombs, E naught is equals to 0.236 volt. Still you have any doubt how we are taking the N? Once again I am explain here. Look at here, Fe plus 3 is converted into Fe plus 2. Means Fe is gaining 1 electron. Each Fe is gaining 1 electron. How many Fe is there here? See, Fe plus 3 is taking 1 electron. Electron charge is minus. Fe plus 3 is take 1 electron, 1 negative charge is converted into Fe plus 2. Okay, means 1 Fe plus 3 is converted into 1 Fe plus 2, means we required 1 electron. 2 Fe plus 3 want to convert into 2 Fe plus 2, means we required 2 electrons. That is a small logic here. That's why here number of electrons is equals to 2. Keep your mind, number of electrons is equals to 2.
So then substitute the values. Delta Z naught is equals to minus 296,500 0.236. And let us go to the simplification. Then this all are simplification you can easily do by using simple mathematics. Then you are getting delta Z naught value in the form of joules is this much, minus 45,548 joule per mole. Now let us go to the kilojoules. You should be divided by 1000. When you do divided by 1000, your value you are